Hello everyone. So welcome to this structural isomerism synopsis. So this isomerism will cover in two part. So in part 1 we will discuss all those types of structural isomerism except tautomerism, means chain isomerism, position isomerism, ring chain isomerism, functional isomerism, metamers. This we will cover in this segment. So let's start. What is isomer? Iso means same, mer means unit. So same unit will be there, means at least molecular formula will be same and something will be different, means at least one entity will be different, one part. So let's see what will be different. Hard work has no isomer. Hard work has no chain isomer, no position isomer. Keep working hard. Hard work works. So let's start. Compound having same molecular formula but difference in what? Difference in whatsoever that name will come, that only will be different. Means if I am telling a structural isomerism, means molecular formula same, a structure will be different. If I am telling stereoisomerism, means molecular formula will be same, stereo will be different. So that isomers are classified broadly in two types. One is a structural isomerism and one is stereoisomerism. A structural isomerism means a structure will be different. Here stereo will be different. Both will have same molecular formula. A structure will have different structural formula, means different structure means IUPAC name will be different. Whereas stereoisomerism means stereoisomerism will have same molecular formula, different as that same structural formula, means IUPAC name also will be same. What is meaning of that different structural formula and same structural formula? Let's try to understand in a very simple illustration. Let's suppose one person is there. So this normal position of the person, this is both side hand is there and this both side leg is there. Now this person became excited and here you can see that leg position little bit change, hand orientation change. So yes, hand positions are still there at the, means joining of the hand from body is still same, is not changed. So this is same structural formula, only orientation little bit here there changing. But here this person, that same person became super excited. Oh, something happened here. You can see that instead of hand, leg came here, and instead of leg, hand came here. Something different. So this is different, a structural formula with respect to this person. So you understood that a structural isomerism means their structure will be different, but in stereoisomerism, a structure will be same, only orientation here there, it will change its position. So let's start. First we will discuss that a structural isomerism. So a structural isomerism having several types. You can see chain isomerism means molecular formula will be same, chain will be different, main chain or sometimes side chain also will be different. So here you can see 4 carbons main chain, here 3 carbon main chain. Molecular formula is same. So always whenever isomers, if it is asking which isomer and you need to check, first you check its molecular formula, whether molecular formula is same or different. If molecular formula is same, then you go for other types, chain, position and all. Ring chain isomers. Ring chain isomer means one will be ring and one will be open chain. So this both are ring chain isomer, molecular formula is same. One is cycloalkane and one is alkene. Next, position isomer. So here position will be, position of double bond will change, molecular formula will be same. Here functional isomerism means functional group will change, molecular formula will be same. Meta isomerism means metamers will change, different metamers will be there, molecular formula will be same. This meta isomers we will study that only shown by bivalent and trivalent functional groups, is not shown by that monovalent atoms. Tautomers, in tautomers what will happen, that hydrogen atom oxidation will happen from 1 to 3. So you can see one example here, keto-enol tautomerism, keto and this is enol, both having same molecular formula. So this tautomerism we will study in detail. Next, coming here is stereoisomerism. Stereoisomerism having two types. One is configurational isomer and one is conformational isomer. Definition same way you can define, which having same molecular formula, different in configuration. It is two types, geometrical isomer and optical isomer. Geometrical isomer, you can see molecular formula and structural formula both same, only some here orientation changing, cis and trans, E and Z, like that we'll study. Optical isomer means molecular and structural formula will be same, IUPAC number naming will be same, only what will be, when we will pass PPL lights, its behavior with PPL light will be different. That's why it is called optical isomers. Here conformational means what? Here around single bond, that sigma bond, this will rotate. So due to that rotation, it can form infinite different orientation, and that is only called conformational isomers. So let's start. First we will discuss a structural isomerism, in that chain isomer. So a structural isomerism means what? Compound having same molecular formula different in a structure or a structural formula is called a structural isomerism. First type is chain isomerism. So chain isomerism what? Molecular formula will be same, chain length will be different, main chain length or side chain length also sometime. So find out the chain isomer, one trick we will know. Anyway, we can calculate that main chain will be same or different. But one trick will help you sometime, like here xy, if xy value is different then it is chain isomer, and if xy value is same then it is position isomer. X is what? Total number of carbon atom present in the main chain, and y is what? Total number of carbon, total number of branch chain of carbon, total number of branch chain which is started by carbon. So like here you can see x value is total number of carbon is 6, main chain, side chain 0, so xy value is 60. Here you can see total main chain in that carbon is 4, so 4, and side chain how many carbon? 2, so it is 42. So x and y value is different, so this both are chain isomer. For molecular formula is same, so always first you need to check molecular formula, then after you see this all those difference. Otherwise sometime accident will happen. Now next, here you can see that one important extra point, that whenever that hydrocarbon will be linear, due to that linear it will have more interaction between two layers, van der Waals interaction. So due to that it will have more boiling point, but when it will have more branching, so due to that branching, interaction between two layers will be less, and when interaction is less, so boiling point will be less. So more the branching, less will be boiling point. Yes, but branch chain alkanes are more stable than linear alkanes. Why? Because it will be, due to that branch, it will have more compact packaging. So little bit you can study on Google also about this. Anyway, coming back here, so you can see that this is N-pentane, isopentane and neopentane. Yes, XY value is different. This is also chain isomer. Moving further, here you can see this compound, this one in molecular formula only different. So don't go for any other. So this both are homologous series. Molecular unit difference is CH2 or 14 AMU difference. But both are not chain isomer, not any isomer. Next after that, here also you can see that here how many? One carbon here, one carbon here. This is third carbon, fourth, fifth and sixth, total 6 carbon, but here 7 carbon. Molecular formula is different, so it is not any isomer. Moving further, here you can see this is since cyanide, so we'll start numbering from here 1, 2, 3. So it having here one methyl and here one methyl. Here you can see total how many actually carbon? 5. Here also 5 carbon, but chain isomer is different. So here 5 carbons are there in main chain, here 3 carbons are there in main chain. So both are chain isomer. Here you can see there its principal chain, main chain is same. Total how many carbon? 5 carbon. But side chain is different. So when you will do XY value, X value is 5. Y value here only one branch is started by carbon. So it will be 51. Whereas this one 5 and here 2 carbon is started. So this will be 52. 51 and 52 XY value is different. Hence both are chain isomer with respect to side chain. Molecule here main chain is same. Next, moving further, next you can see here that again cyanide functional group. So numbering will start from here 1 2 3 at 2 methyl is coming 3 membered main chain, but here you can see 4 membered main chain and molecular formula is same, hence it is chain isomer. You can see this one also, that in this example that this is the main chain 1 2 3 4 5. So at 2 ethyl group and 3 methyl group coming. Here 1 2 3 4 5 6 7 8. So total carbon 8 and 2 double bond. Here also total carbon 5, then after 6 7 8. So total 8 carbon, 2 double bond, molecular formula is same. So here at 3 1 methyl only coming, but here at 3 methyl and 2 ethyl also coming. So main chain is different, so both are chain isomer. Next coming here, that bicyclo compound. So you can see numbering we will start from bridgehead and will cover that largest part, then after a smaller. So here 1 2 3 4 5 6 7 8 and 9 means 1 branch chain and 1, this one is the main chain. So total how many carbon? 8 carbon and 1 branch, so it will be 81. Here you can see total in main chain only there, so it is 90. XY value is different, so it is chain isomer. So in nutshell, chain isomer means what will be different? Chain will be different. Sometime if we are stucking, we can apply this XY concept and we'll get that one. Ring chain isomer. Ring chain isomer means one will be in ring format and another one will be in chain. So that's why it is called ring chain isomer, means one will be cyclic segment and one will be acyclic segment. So such type of isomers which having molecular formula same is called ring chain isomer. Here is very important, not important, we can say common point, general point. Each isomer must have at least one DU. If it will not have one DU, then it cannot form ring. So at least it should have one DU. Alkane never forms ring chain isomer because alkane having degree of unsaturation 0. Means neither ring is there and neither pi bond is there. So alkanes never forms ring chain isomer. So here you can see alkene degree of unsaturation 1, cycle also degree of unsaturation 1, molecular formula same, both are ring chain isomer. Molecular formula same, ring chain isomer. Molecular formula same, ring chain isomer. Molecular formula same. Sir, this both are chain? Yes, both are that cycle. Yes, both are cycle, but in that you can say here chain also there. Here chain is also there. So this is both are ring chain isomer. Next, moving further, here you can see this is again chain and this is ring. Here alkane and cycloalkane, no, molecular formula will be different because for alkane molecular formula is CnH2n plus 2. Cycloalkane molecular formula is equal to alkene CnH2n. So molecular formula will be different. So chain completed, ring chain completed. Now we are discussing position isomer. You remembered XY value for position isomer will be same. XY value means X is total number of carbon in main chain and Y is number of branch chain started by carbon. So here you can see compound having same molecular formula. What will be different? Position will be different. Then position isomer. Position isomers, in that carbon chain length must be same. If carbon chain length only always changing, then we cannot. Suppose in class, if number of students always fluctuating, someday 5 students, someday 20 students, then we cannot consider we cannot examine their talents. So when number of students are constant, then we can examine their talents and we can give position also, that this is the first rank, second rank, like that. So that's why when position we are giving means carbon chain length must be same. So let's start. Here trick XY value will be same. So in this you can see total how many carbon? 3 carbon connected to OH. Here also 3 carbon OH. So main chain length is same, only position of functional group here OH is changing. XY value if we will do, X how many carbon in main chain? 3 and Y value 0 because no branch is started by carbon. Here also Y value is 0 because this branch is not started by carbon even though it is not branch. So XY value is here also 30, here also 30, XY value same, hence it is position isomer. Here also you can see but 1 in, but 2 in, both are position isomer. Here also 2,2-chloro, 1,2-chloro, 1,1-chloro. This you know geminal, This one also geminal. This one is vicinal. So this both are, means all three are position isomer. Similarly, all orthogylene, metagyline, paragyline. So 1, 2, 1, 3, 1, 4 position changing, molecular formula same. Similarly, here also you can see OH and methyl. So it is also position changing. This one you know, resorcinol, quinol, catechol. So this also in 6th question, position only changing 1, 2, 1, 3, 1, 4. Here also you can see in this compound what happening, bromine, 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 chlorine, chlorine, chlorine. But here chlorine is there at 2, 2, 2, but here you can see 2, 2, 2 bromine came, and 1, 1 bromine, but 1 chlorine also came, means positions change with respect to chlorine and bromine. Similarly, here you can see if we'll do numbering 1, 2, 3, so at 3 chlorine is coming, at 1 because alphabetically senior, lowest sum rule here same for both, lowest sum rule is constant 1 and 3, so better we will give lowest number to alphabetically senior. So both are identical, it is not different position. Here you can see position will be different. 1 to lowest sum rule also we need to take care. So this both are position isomer. Here also this all three are position isomer. This is geminal. Here this one is 1, 2, 1, 3 and 1, 4. But if it will be benzene, then 1, 2, 1, 3, 1, 4 possible, but this one is not possible. Because benzene, if it will be there here, then carbon will form only one bond. So this one not possible. Understood? So this all those, these three are vicinal, whereas this one geminal. Next, moving further. In that vicinal, which one? Only this one is vicinal. Remaining two are isolated dihalides. Next, moving position isomer. Some examples here, like position. What is 3, 3? Here 2, 3. So position is different. Molecular main chain is same 5 and 5. Similarly, here also you can see that in isocyanide, since it is not started from carbon, so we'll do numbering 1, 2, 3. So it is coming at second position. Here it is first position isomer. Here you can see in this alkoxyalkane ether that here methoxy is there, but here it is connected to one carbon in alkane. Here methoxy is connected to second carbon, so position is different. Similarly, here also position is different. Here also you can see position. You will start numbering from any side, 1, 2, or both are 5 membered. So 1, 2, 3, 4, 5, 6, 7, 8, 9. But here 1, 2, 3, 4, and then after, so this position is different. So both are position isomer, even though both are s-pyro compound. So we discussed chain isomerism, ring chain isomerism and position isomerism. Here you can see this compound. Always remember this, all those terminal functional group will form chain isomer but will never form position isomer. How? Like here you can see this is the, how many carbon here in main chain? 4. If I am changing its position, this functional group carboxylic acid, let's suppose I am keeping at second carbon. So while doing numbering, you know that numbering will start from again carboxylic acid. So 1, 2, 3. So here what happened? Main chain only is sorted, means it is showing chain isomer with respect to each other. Position isomer never possible, means if it is 1, always it will be 1. Similarly, this one also terminal functional group, always 1. Cyanide also always 1. So such type of isomers will only show chain isomer, position isomerism not possible. Next, moving further, now we will discuss functional isomer. So functional isomer, in that what? Molecular formula will be same, only what will be different? Functional group will be different, like ether and alcohol. So ether you can see, and this is alcohol, molecular formula same. This is cyclic ether and this is alcohol. Similarly, alcohol and phenol is two different functional groups. So you can see this is phenol, whereas this one is alcohol. Similarly, this is aldehyde and this one is ketone, molecular formula same. This is aldehyde, this is ketone, molecular formula same, only functional group is different. Carboxylic acid and ester. So you can see this is carboxylic acid, one CH3 came this side, so it became ester. Carboxylic acid and ester. Thiol and thioether. So thiol is what? Instead of OH, SH is coming, so it is thiol. and thioether, this one. Similarly, cyanide and isocyanide, CN and NC. Molecular formula same, functional group different. Molecular formula same, nitro, and this is nitrite. Similarly, 1 degree, 2 degree amines, all three are different functional group in isomerism we have studied. So this all molecular formula same, 1 degree, 2 degree, 3 degree. Amines are different functional group. Similarly, 1 degree, 2 degree, 3 degree amides, molecular formula same, are different functional group. Sometime more than one functional group also will be there. Like here you can see this is amide, and here you can see 3 degree amide. So both are functional. Similarly, here you can see this is aldehyde, whereas this one alkene plus alcohol, molecular formula same, so both are functional isomerism. Here you can see diene, whereas this is alkyne, both are functional isomerism. Next, moving further, this although you can see here same again miscellaneous, this is ketone and chloride. Here you can see acid chloride. So here two different functional group, here one functional group, acid chloride. Similarly, you can see this is phenol, this is ether and alcohol, molecular formula same, very famous question. So this is functional isomerism. Similarly, here you can see ketone is there, and here also ketone, and this is ether, right, ROR. But here you can see this is ketone, ketone, no, this one we can say ester, and this one is ketone. So ester and ketone, molecular formula same. Here you can see molecular formula same, this is anhydride. So this is also very important example. Ketone ether, ester ketone and anhydride, all three are functional isomers. Similarly, here nitro and nitrite. Next, moving further, metamerism. So metamerism means what? Molecular formula will be same. What will be different? Alkyl or aryl position with respect to bivalent functional group. First of all, which one will not form metamers? All monovalent, like primary amine, OH, SH, this all those carboxylic acid or its derivative, nitro compounds, this all those lithium, sodium, this one fluorine, chlorine, bromine, iodine never forms metamers. So who will form metamer? All those polyvalents, either divalent or tritetravalent. So you can see here divalents, trivalents, this all those can form metamers. In metamers, functional group remains same, functional group will not change. So here you can see this is ester. So here this side 2 carbon, here 2 carbon, but here 1 carbon, here 3 carbon, metamers. Here again 2 carbon, but here 1 carbon, and this means 3 carbon, metamers. Similarly, with respect to NH, primary amine. So here also primary amine. Here we can say that amide, and here also amide, 2 degree amide. So with respect to 2 degree amide, both are metamers. Similarly, here you can see one side phenyl and one side cyclohexane with respect to O. Similarly, here both are same right now. Even you just like this, there we interchange like this. Are you understanding? So identical, molecular formula same and identical, but here it is different. Here it is with O, this phenyl ring is connected, but here that cyclohexane is connected. Yes, both are metamers. Similarly, here you can see that 3 degree, so 3 degree amine. So here this methyl and this one, but here ethyl, so this is metamers. Similarly, this is acid anhydride. So this side symmetrical, whereas here unsymmetrical, anhydride only. So functional group remains same here. Functional group will change in functional isomerism. Here also you can see C double bond O, and along with that here this is ester. So here CD3 and here CH3. Now CH3 is here, CD3 is here, and CH3 is here. Both are metamers. This is also metamers, this is also metamers. Now one interesting question asking that draw hydrocarbon with least molecular weight can show chain isomer. So for chain isomer in alkane, minimum carbon is required 4. So you can see for 4 carbon, one is linear and one is branch. So this is chain isomer. Ring chain isomer alkane will never show because the degree of unsaturation is 0. Position isomer, yes, it can show. For position, how many minimum carbon is required? 1 2 3 1 2 3 4 5, and here carbon is there at 3, here carbon is there at 2. So yes, both are position isomer. Means minimum how many carbon required? 6 carbon. Then only with respect to 5, either it could be at 2 or 3. Similarly, in alkene also, chain isomer, ring chain, and position you can go on. Similarly, alkenes, and in alkynes also, chain, ring chain, and position isomers. Next, moving further, here we will calculate counting of a structural isomerism. So there is no any formula to calculate counting isomerism. Always you have to go by heat and trial method. So like here you can see C4H8 is there. So first you calculate degree of unsaturation. So degree of unsaturation 1 means either it will be 1 double bond or ring. So double bond, 4 carbon. So first linear like this, position at double bond, next position at second, and then after 1 branching. Only this 3 possible. Whereas in ring, 1 4 membered and 1 3 membered. That's it. So total how many isomers here? 5. Similarly, you can calculate for C5H10. So C5H10 degree of unsaturation again 1. So 1 cycle and 1 double bond system. So in cycle 5 membered, then after 4 membered, in 3 membered ethyl group, then after 1 comma 1 methyl or 1 comma 2 methyl. In alkene it will be 5 membered along with that double bond at 1, then after at 2, 3 not possible, then after we will start branching. So at 1 double bond, 1 carbon will keep here, another again we can change position here, and then after 3 or that same only 1 2 3 4, and this is at third position. Here it was with respect to double bond is at 1 and carbon was at 2 and 3 respectively. Now double bond is at 2 and carbon is of course minimum it should be at 2. So total how many possible alkanes? 5 plus 5, 10. Similarly, you can calculate remaining also here, that calculate total possible aldehyde and ketone. So degree of unsaturation again coming 1. So only we have to tell aldehyde and ketone. So aldehyde, you know that terminal functional group. So terminal functional group 5, then after 4, then after 4, here position at 2, then after position at 3, and then after 3 membered with position 1, position 2 and 2. Then after ketone, so in ketone will be at, is not terminal functional group, so at 2, then after it will go to 3 also, then after not possible, then do branching. So in branching only this is possible. So total aldehyde 4, ketone 3. Similarly is given C4H11N, all amines. So you just see and then after try to calculate by yourself. Degree of unsaturation 0 means it is not amide and all, it is amines only asking. So all amines 1 degree, 2 degree and 3 degree you draw. So first you draw for 1 degree all possibility, then after 2 degree and then after 3 degree. So this is clear. Next, should I discuss this one? Okay, let's complete this one quickly. So you can see this one, primary amine with respect to that 4 carbon, then after at second position this one sorted, then after 3 membered carbon will keep here, again primary carbon we can exchange here, and then after carbon and amine both positions. So total how many? 1 degree, 5. Next after 2 degree. So if you will do systematically properly, you will get the answer. There is no any formula and all, there is no any shortcut. So here you can see 2 degree amine. So for 2 degree amine again 1, and this side 1 2 3 carbons. Now one what we can do, this side 1 carbon, here we can create branching. Any other possibility? Not there. So 2 degree 2, 3 degree only 1. So total for this side is came 4 5, and then after 2 7 and 1 8. So total 8 isomers. Similarly you can here also you can see calculate total number of structural isomerism of 3 degree amine with formula. So these are the So once you try by yourself and then after match the answer. So there is no any rocket science, just simply you have to draw all possibilities. Sometime it will be that 1 2 missing also, but if you will do sufficient practice, then you will get the answer. So this all those you can do by yourself. C7H8O. So all possible benzene structure in that. So this is the benzene structure, means 6 carbon and 6 hydrogen. In that 1 hydrogen here we remove and keeping CH2OH or OH. So this will be ortho, then after meta and para, and one will be ether, anisole. So like that total 6. Similarly, that find out total number of cyclic structure for this formula. Similarly, draw the all structural tautomeric enol molecular formula. Means enol means ketoenol, like that. So here you can see this enol formula, enol molecular. So this all those are enol. This all those are enol. This all those are enol. So all enol only tautomeric enol format we have to draw by using C4H8O molecular formula. So just see the that questions and then after attempt and match the answer. Draw all cyclic ether. Draw all cyclic ether. So here you can see these all those are cyclic ether. So 5 membered, 4 membered. Then after position we can change 1. Then after 2. Then after 3 membered. In that 1 2 or 1 1 or ethyl, like that. Similarly, draw all structural formula with C4H10O. So all structural formula, alcohols, all alcohols covered, then after ether, done. Next, total number of structural isomerism given by compound C4H6. So degree of unsaturation 2 means how many double bonds should be there? Double bond should be 2 or triple bond should be 1 or ring should be 1 along with that double bond. Then only degree of unsaturation 2. So like that all possibilities you try to match by yourself. Similarly, this all those questions. What type of isomerism cannot show a compound molecular formula C20H42O? So it will not show ring chain isomerism because its degree of unsaturation is coming 0. Degree of unsaturation must be 1 at least to show ring chain isomerism. Next, number of structural isomerism possible when one hydrogen of given compound is replaced with chlorine. So where you can keep? One you can keep at alpha position, then after this one is beta, then after this one is gamma. So like that means here 1 or here 1 or here 1. This only 3 positions we can replace. This one from NCERT, you remember this one is very important, very crucial, that how many structural isomers is possible. So methane having 1, similarly ethane having 1, propane having 1, then after 2, then after 3, then after 5, then after 9, then after 18, then after 35 and 75. So you remember this overall till 10. This is given in your NCERT also. Total number of structural isomer. So 1 1 1, 2 3 5, 9 18, 35 75. Okay. Now after this we will discuss in part 2 that tautomers. So tautomers we will start in part 2. Thank you very much.